In this video, we discuss learning outcome number 2, which is all about computing and interpreting percentiles and finding the percentile of a given value. So z-scores were a measure of relative standing because they told us where our particular x value stood relative to the mean in terms of the number of standard deviations that that value was above the mean, or possibly below the mean if the z-score was negative or if the value was less than the mean. In this section, we're talking about percentiles instead. This also gives us a measure of relative standing. So here's the definition. Percentiles are measures of location. They're denoted p sub 1, p sub 2, p sub 3, p sub 4, all the way through p sub 99. And basically what they do is they divide our set of data into 100 groups. And in each group, you have about 1% of the data values. So p sub 1 is supposed to be approximately that first 1% of the data values. P sub 2 is the next 1%, p sub 3 is the next 1%, and so on. And p sub 99 is that top 1% of the data values. Now, there is no universal agreement on how to compute these. If you use Excel to compute percentiles, or another program to compute percentiles, or your graphing calculator to compute percentiles, you might get slightly different values every time. But our textbook is using a particular formula for computing percentiles. I'm going to present that to you here. So we'll be able to use that to consistently find the percentile associated with a data value. But just know that there is no universal agreement on this. So someone else might use a slightly different formula and they'd get a slightly different answer. So here is the formula that we will use in our class. The percentile of a value x is the number of values that are less than x divided by the total number of values. So it's sort of giving us a proportion. It's saying how many of those values are less than x out of the total number once those values have been sorted. And then we're saying, okay, well, once I know what that proportion is, what percentage is that? I'll multiply by 100, and that's giving me what's called the percentile of that x value or that data value in our set. So let's find a percentile. These are Airport Verizon cell phone data speeds listed in increasing order. Now, if the data set wasn't already listed from smallest to largest, we would have to sort the data first. That's easy enough to do in Excel. Then we are asked to, find the percentile for the data speed of 15.1 megabits per second. That is at the end of this third row here. So in order to use that formula, we're going to need a couple of things. We're going to need to know how many data values we have on our list, and then we need to know how many data values are less than this 15.1. Because we're using this formula again. We say how many values are less than x, and then how many values are there. And then we're saying how many values, what's the proportion of values that are less than x? That's this fraction right here. Then we're multiplying that by 100% to get the percentile. So we need to know the total number of values. So let's count the rows and the columns, and we'll just multiply those, the number of rows by the number of columns to find the total number of values. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns and 5 rows. So 5 times 10 is 50. So that tells me I've got 50 values. So the total number of values in that denominator, it's typically denoted by n, that's 50. And then the number of values less than x, I believe that would have to be 29, wouldn't it? So if there are 10 values in this first row, and then values 11 through 20 are in the next row, values 21 through 30 would be in the third row, but the number of values that are less than that 15.1 are 29. We'd have these 20 plus these 9 right here. So I've got 29 values out of 50 that are less than x, and we want to know, like, well, what is that percentage? What's the percentage that corresponds to 29 out of 50? Well, then we multiply that by 100. So if I take 29 out of 50 and I multiply by 100, I get 58. So that means that 15.1 is the data value at the 58th percentile. So we would represent that as p sub 58, and that's 15.1 megabits per second. Now, the way you want to interpret this, and this is very rough because of the formula that we use to calculate it, the way we interpret this is that about 58% of the data values are less than 15.1, and about 42% of the data values are greater than that 15.1. Now, this isn't perfect because sometimes you've got data values that are repeated, and of course, different software computes this percentile differently. But this is roughly how we interpret it. The bottom 58% are less than 15.1, and the top 42% are greater than 15.1. I guess we should say less than or equal to or greater than or equal to, just to be inclusive. Okay, so these are the notation, this is, excuse me, the notation that we use for the different variables. We tend to use n for the total number of values in the data set. You'll hear n, this lowercase n, referred to as the sample size. K is the percentile that we're interested in. So our textbook author is using this variable to represent the percentile. So when we were looking at the 58th percentile on that last example, K was equal to 58. Or for example, if you're looking at the 25th percentile, K is equal to 25. Now, L is what's called the locator. This is going to give us the position of a data value. It's going to give us that location relative to all of the other values in your data set. So with n equals 50, like we had in the last example, there are 50 different locations. There's the first value, and then there's the 50th value, and then there are all of the values in between. This L is going to help us locate that position of a value on that list. So for example, if you're talking about the 12th value in the list, L is equal to 12. And P sub K represents that kth percentile. That means K percent of the values are less than the particular value of the kth percentile, and the rest of the percent, let's say it's going to be 100 minus K percent are greater than that particular value. So P sub 25 is the 25th percentile. That means roughly that 25% are less than P sub 25, whatever that value happens to be, and 75% of the values are greater than P sub 25. Now this is a flowchart. I think it's an excellent flowchart. It allows you to convert from a percent to a data value. This is in page 116 of our text. This is the algorithm that we're going to use to find a percentile in a data set. So here's the outline of it. Basically, we're going to sort the data. You put it in order from smallest to largest, and then you compute that locator. So if you're looking for the 25th percentile, you want the value that is 25% of the way through your list of data. So you take that 25% in either decimal form or the form of a fraction, which is what we've got here, this K over 100. K over 100 is the fractional equivalent of that percent. Like if we were looking at 25%, I could write that as the decimal point, 0.25, or I could write that as 25 over 100. So I would say 25% of the number of values n. So I take the 25% and I multiply by n to get the locator for a value at the 25% of the way through the list. Now, if L happens to be a whole number, we're actually not going to look at that data value. We're going to say at that point that the kth percentile is not that data value, but it's halfway in between that value and the next one. So if L is a whole number, and let's say L is 20, we're going to say that the kth percentile, or the 20th, or not the 20th percentile, or if L is equal to 20, we're going to say that the kth percentile is halfway between the 20th value on the list and the 21st value on the list. Now, if L isn't a whole number, you're just going to round up, and that number that you see there is going to be called the kth percentile. I know that was a lot. We're going to do an example. Okay, so here's our example. We've got data speeds again, and this time we want to convert from a percentile to a data value. this says find the 40th percentile, and then it says denoted by p sub 30. That's a typo. It should be the 30th percentile. So I want to find the 30th percentile, which means I want the value that is, if I have this data sorted, that separates the bottom 30% from the top 70%. The way we do that is first we compute the locator L, and then we identify K and N. Since we're interested in the 30th percentile, K is equal to 30. Since we've got 50 data values, N is equal to 50. So you're basically taking 30% of 50, and that's telling you, look at the 15th value on the list. Now, at this point, you don't just look at the 15th value on the list, you look at whether or not L is a whole number. Since L is a whole number, we don't take the 15th value on the list. We want the value halfway in between the 15th value and the next one, so the 15th value and the 16th value. That is going to be the 30th percentile for this data set. So here's our answer. If I have this sorted data and it's already been sorted for us, I go to the 15th and 16th values. So in the first row, that's values 1 through 10, and then I've got 11, 12, 13, 14, 15 is right here, 16 is right next to it. And then I want the value halfway in between those. So I just compute the mean of those two numbers. You'd say that the number halfway in between 10.2 and 10.3 is 10.25. Or if you're not sure how to find that value that's halfway in between, just add them together and divide by 2. That's going to give you the number that's halfway in between. So that's the 30th percentile, or in other words, we're going to say that the 30th percentile is denoted by p sub 30, and it's equal to 10.25 megabits per second. And again, what that is saying is that approximately 30% of the values are less than that 10.25 megabits per second, and approximately 70% of the values are greater than that 10.25 megabits per second. So that's it for that learning outcome. I'll see you in the next video.